Integrated 1. Today we're going to actually do 10-6, 10-7, and 10-8 all together. It's just different subjects that you've already either had or had a while ago, and we're just going to go over them all together in bulk. And so the first thing they talk about, and this is kind of all about two-dimensional things. It's just a conglomeration of many things. So first thing is a polygon. So a polygon, I guess a definition could be any figure formed by closed line segments. And so remember, a polygon is two-dimensional. And so there are different kinds of polygons. There's rectangles, triangles, octagons, those type of things. So those are polygons. There are concave polygons and there's convex polygons. So an example of a concave kind of has a part like caved in, and so that is still a polygon, but it's not a convex one. A convex one is more like that. Okay, and so like this concave one has 1, 2, 3, 4, 5 sides. This is an irregular concave pentagon because a pentagon has 5 sides. Okay, a convex, 1, 2, 3. This one is an irregular convex pentagon. So that's kind of the difference. So then those were both irregular. What are the regular ones? The regular ones have congruent sides and angles in them. They're the perfect ones, you know, like the equilateral triangle or the square, everything's perfect about it, or the stop sign, that octagon. I can't really draw it, but the stop sign, we'll just put stop in there, just pretend it's regular. So everything's very symmetrical about it, and it's a perfect one. So they will give you some that are regular, where it's got the same side lengths, all the side lengths and all the angles are the same. So they may mark those like that, okay? Conic sections, which you may have heard of, maybe not. They're 2D shapes made by cross sections, really. And so an example of it would be taking like a sphere, which is 3-dimensional. Try to do the best I can here. And cutting that sphere in half and opening up that sphere and looking on the inside, and what you would see is a circle. So a circle is actually a cross section of a sphere. And, you know, ovals are made this way, curved, anything curved, curved shapes, curved two-dimensional shapes really is what we're talking about. So those are the conic sections, okay? All right, so that's kind of it for the vocab, and then they are going to want you to know your prefixes. So we need to know them up to 10. So if it's triangle has 3 sides, quad is 4, 5, 6, hept is 7. Could also be called sept sometimes, but most of the time we go with hept. Oct is 8, nona, 9, deca 10, and engon is any amount of sides. Okay, so we do need to know those, and we will actually go more over this. I'm going to ask you guys if you haven't done this formula much, but if you want to find the interior angles of any convex polygon, so like let's say it's a 5-sided shape, okay? If we want to know what all 5 angles add up to inside, then you just need to do n minus 2, where n is 5 minus 2 times 180. And that's 3 times 180, or 540 degrees. So pentagons equal 540 degrees. We know triangles equal 180. We know quads equal 360, 540. Every time you add a side, you're going to add 180. That's another thing you could remember. But this formula is easier. Okay, so we're going to see how much you've done of that formula. If we haven't done much, we are going to spend some time on it this week. Area and perimeter. We did this at the beginning of the year. Parallelograms are... Well, let's just do area, and we'll make a little thing here, and perimeter. make it easier. So area of a parallelogram is base times height. Okay, parallelograms take care of squares, rectangles, rhombi, parallelograms themselves. Any parallelogram is base times height. So like the square and the rectangle, we always say length times width, but it's just really base times height. And then perimeter is basically 2 lengths plus 2 widths, or 2 bases plus 2 heights, however you need to see that. Okay. Triangles. Triangles are half of a rectangle, so half base times height, or base times height divided by 2, whichever one you like to use, it's up to you. And then the perimeter of a triangle is just A plus B plus C, whatever the 3 sides happen to be. There are different ways to find the sides of triangles that you'll work on for the next 2 years. Trapezoids. Usually you'll see it half of base 1 plus base 2 times the height. And these two right here, the bases, are the parallel sides. Okay, so just so you know. And the perimeter of a trapezoid, that is once again found in different ways. You might have to make 2 different shapes, so this varies on how you do that. And then a circle is pi times radius squared for the area, not to be confused with the perimeter or the circumference, which is 2 pi r, or you can use pi d. Okay, so you can see why the pi r squared and the 2 pi r formulas get mixed up, because they've got the same numbers and letters, but they're not used in the same way. Okay, also the Pythagorean theorem, we're going to find out how much you know about this during the week, but it is a squared plus b squared equals c squared, where you've got a right triangle, and you've got A, B, and C is the hypotenuse. So you just have to make sure to plug it into that formula correctly. Like I said, we'll work more on that during class also. Angle theorems, lots of angle theorems that you're going to be using throughout this. Complementary, 2 angles that add up to 90. So something that looks like this, where you have angle A and B. So A plus B equals 90 degrees. Supplementary is the 180. I always remember supplementary is a straight line and complementary is a corner. And so supplementary angles is A plus B, angle A plus B equals 180. Okay, so if they ask for something supplement, you just need to take 180 times minus the one that they give you. Vertical situations are when you have 2 intersecting lines and vertical angles are made across from each other. So these 2 angles, I'll just say star and star. Those are equal to each other. So if they're 60 degrees, they are. If this is 120, so is the one across from it. Those are vertical angles. They go across from each other. All right, and then the last part is parallel lines cut by transversal. So we'll see how much you know of this when we get to school. So if you have parallel lines, they'll mark them by the little triangle things, and they will say that it's going to make 8 angles. Okay, so there's different angles made. There's many vertical angles made. Okay, so for example, a vertical angle that's made is 1 and 4. Those are vertical. 3 and 2 are vertical. 5 and 8 and 7 and 6 are all vertical. So they may ask you for the pairs of vertical angles. It just kind of depends. But there's other angles made that we're going to know the vocabulary for. So the first ones we're going to talk about are the alternate interior angles. So the alternate interior angles are on alternate sides of that transversal T. This is a transversal T. And they're on the inside of the parallel lines. We'll just call it A and B. Okay, so that makes it so it has to be alternate sides. It has to be 3 and 6. And you can visually see the openings for 3 and 6 from here to here and here to here. Those have to be the same. And so we know that 3 and 6 are congruent to each other, and that's the secret about alternate interior angles. And so the way you would write that is angle 6 is congruent to angle 3. That's one pair of them. And another pair of them would be angle 5 is congruent to angle 4. Those are your two pairs of alternate interior angles for this situation. Now there's also alternate exterior. And so those are on the alternate side of the parallel line, but they are exterior to it. And so we're talking about angle 8 and 1. You can see those are on alternate sides of that T, but they're on the outside of that parallel lines. And we've got 7 and 2. So if we label those, we have angle 8 is congruent to angle 1, and we have angle 7 is congruent to angle 2. Those are your alternate exterior pairs. Now, we've got corresponding. These correspond with each other. And so what that means is they're on the same side of the parallel line and they're on the same side of the transversal. So 4 is on the bottom of A on the right, and so the other one that's on the bottom and right is 8. 4 and 8 correspond. 5 and 1 correspond. 2 and 6 correspond. So there's actually more of these, and so we're going to just write them down there. So we know that, we'll just start with angle 1 is congruent with angle 5 because it corresponds. We've got angle 3 congruent with angle 7. That's a corresponding pair. Angle 2 is congruent with angle 6. And we've got angle 4 is congruent with angle 8. You have 4 sets of corresponding angles. All right, and so the last one is called co-interior. And basically, these co-interiors equal 180. So they're on the inside, but they're on the same side. So like 4 and 6. So you're going to say angle 4 and angle 6 together, if you were finding it, equals 180. Okay. Also the other pair, angle 5 plus angle 3 equals 180 degrees. Okay, so if you know one, you can find the other. There's also co-exterior. All right, so co-exterior would be like angle 1 and 7. They equal 180 because they're on opposite sides. Because since 1 equals 8, and 8 and 7 make 180, that's why. And then 2 and 8 equals 180. I don't think you're going to use the co-exterior one as much as you're going to use the other ones, but those are the sets of them. And so a lot of the questions that they're going to use are just asking you what kind of pairs they are. Okay, so if they ask you, give me a pair of alternate exterior angles, then you might say 1 and 8. Okay, the problem is that with this particular book, they're going to make things that kind of look like this, where they're not going to look necessarily very nice. And so if I had 2, 3, 4, 5, 6, 7, 8, and I wanted a pair of alternate exterior, they're not going to necessarily look like they're equal. It's still going to be in that placement. So it's the placement. Angle 1 and angle 8 are alternate exterior. Corresponding, whether they look like it or not, corresponding set of angles might be like 7 and 3. Okay. The only reason why alternate exterior corresponding alternate interior are equal is only if those two lines are parallel. That doesn't mean that we can't find the pairs without them being parallel. Okay. So if they're not parallel, it's just that these angles aren't going to be equal to each other. If they are parallel and nice and everything, then those angles are equal to each other. That's just the difference. But in the book, they just ask you to find some of the pairs, and they don't give you the parallel lines. So just use the location of these angles to help you find that.